In section 3.2.3, we continue solving equations, and we're going to use them to solve problems. The section started out in problem 87, going back to section 3.1.3 where we did the growing pattern that looked kind of like a C. And we discovered that when we did that, we got this rule, y equals 6x plus 3. And one of the things that we want to do with that is we want to look really carefully. In this pattern, we use the figure number to represent x, and we use the number of tiles to represent y. So when we're working with a rule, a lot of what we do as far as solving the equation will depend on what information they give us, whether they give us a number of tiles or they give us a figure number. So let's go ahead and mark here really quick that the x represented the figure number and the y represented the number of tiles. Okay, so let's read the problem that they gave us. They said that Penelope wants to know how many tiles will be in figure 50. So if we want figure 50, we asked several students to identify where the number 50 would go. And since it's a figure number, it's going to go right there. And for x, and so our equation becomes y equals 6 times 50 plus 3, because that is our figure number. Simplify, 300 plus 3, 303. So y equals 303. Now y represents the number of tiles, so this is 303 tiles. We can also use this same rule to find the figure number. In problem 88, they said Lou wants to reverse this process. He says he has a big C's figure made up of 45 tiles. He wants to know which figure number made this pattern. So this time, because we're given a number of tiles, we will need to insert the number in for y. I'm going to write my rule just so we can follow and know that we're starting over again. And this time, we're going to put the number 45 in for y. 45 equals 6x plus 3. So we're going to be able to solve this now for x, or the figure number. Now remember when we were using the tile mats, we're still talking about how we're going to deal with movement on an equation. In other words, if I want to get my x's by themselves, all my x's are here, but they have some units with them. To move those units, when I move them across the equal sign, I need to change them to their opposite. So now I have 45 minus 3 equals 6x. I basically took the 3, took it across, moved it over, and made sure to change it to its opposite. 45 minus 3 is 42, and 42 equals 6x. Remember, we divide by the number on the variable we want to get by itself. And we get that x equals 7. So x equals 7 should be our answer. And that would be the figure number. So this is the answer, is figure number 7. We can check our answer. Okay, and that was one of the things that we've been practicing. By taking this first equation where we plugged in the numbers, 45 equals 6x plus 3, and we're going to plug the 7 in for the x this time and see if we get the same value on both sides. 6 times 7 plus 3. 6 times 7 is 42 plus 3. 42 plus 3 is 45. And does 45 equal 45? It does. So we know that that is the correct answer. Okay. Then they gave us another problem. I'm going to write the rule on here for us again, because we're going to end up using it again. And on this one, they basically said that Norm says he has a big C pattern made up of 84 tiles. He wants to know which figure number the pattern is. Write and solve the equation as you did in problem 388. So we're going to basically use the same process. We'll plug this number in for y, and that number was 84. Okay, we're going to end up moving our 3 over for the next level of the step and changing its sign, which will give us 84 minus 3 equals 6x. 84 minus 3 is 81. Okay, divide by the number of x's. Remember, it's the variable that we want, and in this case we want to know x. And I'm not exactly sure what that equals, so let's find out. 81 divided by 6. So we get that that equals 13.5. Now, we're going to check it really quick. We're going to go back to this level right there. So we're going to go 84 equals 6 times 13.5 plus 3. And 6 times 13.5 is 81. Get 84 equals 84. And so on our check shows that we got it all right. So it does check. Okay, I then gave you, or the next thing that we have to do is they just give you practice solving some problems, particularly with fractions and decimals. Before you do that, I want you to look and back at what we did in the previous unit. When solving a linear equation, basically something that creates a straight line, if we solve our equation down to the end and we get our variable equal to a number, we said that we have one solution or one answer. If we come and as we're solving we get down to the same thing on both sides, I think you can see that if I plug in the same number in both places, I will always get the same number on both sides. So for example, if I plug the number 5 in, I get 5 plus 2 equals 5 plus 2, which is 7. So 5 is an answer. If I plug 6 in, I get 6 plus 2 equals 6 plus 2, or 8 equals 8, which means that 6 is an answer. If we continued solving, we'd actually get it simplified into something like this. A number equal to the same number, a number equal to the same number. When that happens, when we get the same exact thing on both sides, we say it has many solutions, or a more accurate way to say it is it has infinite solutions. We said we could also solve down and have our variable disappear. There's no x's in our solution here. And we will get different numbers sometime. 2 equals 7, 5 equals 1. Well, those don't make sense, and that's one way that you know that it has no solutions. Now we need to be careful. If I have this,